First of all, I'd like to thank Dr. Basker for organising my talking today and all of his colleagues at RIT. I'm greatly honoured to be speaking with you today and sharing some ideas from Melbourne, Australia. I also want to do a shout out to Shreya Goel, who I met in Pune at a conference at ISA. Before I continue, I just want to say my background is an economist, but my passion is in mathematics. I decided to fix mathematics long ago, and as it happens, I have a son, Ashley, who has a master's degree in electrical engineering, and I have another son, Jared, who's just finished a PhD in quantum chemistry. So if I just quickly go over the outline of the talk, we're going to be looking at some of the concepts of mathematics, the way I interpret mathematics and the foundations. I'm going to discuss some of the aspects of arithmetic that are problematic, and then move on to zero and introduce my own mathematics framework called Podometic, and then finish off with some concluding thoughts. So in terms of the concepts, the way I discuss things, elementary applied maths foundations concern counts, measures, and relationships between physical quantities that reveal predictable patterns. And those elementary physical quantities are energy and matter. So in my mathematical framework for reviving zero in a symmetric form, I assume a closed system of energy and matter. I assume all quantities of mass are conserved. And this is the structure that supports people researching in the areas of physics and also chemistry. So moving on to the era of arithmetic, and I also mean that in its pejorative term because I'm not too impressed with the way that mathematics has evolved over the last 1400 years. So let me ask some questions. Firstly, what is zero? And I'll give you the standard answers that people give to mathematics students in lower levels of schooling. And as zero is defined usually as a number subtracted from itself. For example, 5 minus 5. What are negatives? Negatives are simply less than zero. What is greater? -7 or +3. We'll usually say +3. What is multiplication? Repeated addition. What is exponentiation? Repeated multiplication. What is division? Repeated subtraction. These are the standard responses to these sorts of questions. If we also look at the definition of multiplication of A into B or AB, that's been defined as A added to itself B times since February 1570. If we say what's the definition of an exponentiation, A to the power of B, that's been defined as A multiplied into itself B times. And if we ask why does -1 into -1 equal +1, the standard response from Western pedagogy is it's by definition to preserve the distributive property of multiplication. So I suggest that if the universe is written in the language of mathematics, and you might have heard that expression or that cliche before, if the universe is written in the language of mathematics, the era of arithmetic is over. We've got feedback from crores of brains, tens of millions of brains around the world that children dislike mathematics. And in my judgment, it's because the foundations have not been correctly established. Under the idea that the era of arithmetic is over, the reason I say that is that the previous Greco-Anglo or Greek and English concepts failed to agree with India's original zero-based empirical observations made by scientific astronomers. So those ideas that I mentioned just before in terms of zero, multiplication, exponentiation, division, inequalities, and so on, the way that we explain those to children when we start to teach them mathematics is totally illogical in many instances and quite damaging to the pursuit of an understanding of our physical world. So how did this happen? The West misplaced zero. So I'm going to whiz through a little more quickly than I might otherwise because I know that we're pushed for time. We've got three key mathematicians from the golden age of Indian mathematics. We've got Aryabhata, we've got Bhaskara the First, and we've got Brahmagupta. Now, it's Brahmagupta that I'm particularly focused on in the concept of zero or shunya, because this is the key issue that lays at the heart of the problems in explaining the foundations of mathematics. Just as left and right cannot exist without a centre, you cannot have the relational concept of positive and negative without a zero. Similarly, with above and below, zero is neither term but formed from both. Now, Brahmagupta's zero is between positive and negative, being defined as the sum of equal positive and negative. So a simple conceptual diagram shows that we have a midpoint in our concept of quantities, where on one side we might have positive quantities, on the other side of zero we might have negative quantities. We can see that zero is the least quantity you can have. You cannot have any quantity of matter or energy that's less than zero. So we've got a symmetric structure here, and I call this the Brahmagupta line because it really reinforces that zero has ones on either side. But, as I say, the West misplaced zero. So we look at a rotary dial telephone, and there you can see that the zero comes almost like an afterthought after the number 9. So rather than the start of number, it's almost tacked on like an afterthought. What about the typewriter? Well, there's a Hindi typewriter, and you can see that the zero on the old typewriter comes after the number 9. And if we move to the modern day, we can also look at our keyboards and our computer, and again we see that the zero is in the wrong position. It's in the placeholder position, because that's been the concept of zero that has come to dominate Western mathematics pedagogies, not its original definition. If we look at this map, on the right-hand side of this map, we've got Brahmagupta. In the middle, we've got Al-Khwarizmi. On the far left, we've got Fibonacci or Leonardo Pisano. And at the top left, we've got Robert Record. These are the people who are perhaps most influential in the development of mathematics. So let's zoom in a little closer and see exactly what's happened. So we've got Brahmagupta, who defined zero by addition, whereas we usually think of zero as being what you get if you take everything away from something, like 5 minus 5. But Brahmagupta defined zero as a sum of equal and opposite positive and negative quantities. So in the arithmetic that he wrote in chapter 12 of his Brahmasvita Siddhanta, that seemed to have travelled to the Middle East, but the laws or the sutras, the 18 sutras of symmetry that he documented in chapter 18 on algebra, didn't seem to travel on its journey west. So those people in the history of the development of mathematics who were unaware that zero was defined as the sum of equal positive and negative include Al-Khwarizmi in Iraq in the 9th century, the traders in North Africa in the 12th century, Leonardo Pisano or Fibonacci, the Italian who brought the Arabic number system, as it was called, into Europe, and also Robert Record, who his book was published for about 150 years on arithmetic, and that really cemented the ideas of Western arithmetic in Europe, which then got carried around the world by the British Empire. So when we get to London, we have the idea of Robert Record. He didn't know about Brahmagupta's zero definition or his 18 sutras of symmetry for zero, positives, and negatives. So let's have a look at a person who's very influential, because this guy led to our concept of the number line. This is John Wallis, who in 1685 drew a number line in which he started at point A, which I've just put an origin, an O or a 0, and he moved 5 yards east to be at B, or at 5 east. And then after moving 5 east, he then moved 8 west to appear at D. So altogether, he had travelled 3 west. But what happened is, in his explanations, he then said that he had advanced 3 yards less than nothing. So that's why we today talk about negatives being less than 0, because this caught on as a concept, believe it or not. I've got many videos that are freely available on my YouTube channel, which is Podometic. Now, when I consider what are the requirements for a new mathematics framework, so the mathematics agrees with all the laws of physics as well as common sense, I had a closed system of energy and matter, all quantities of mass were conserved, and 0 was, most importantly, a sum of equal positive and negative. So that got me to the age of Podometic, which after almost around about 38 years, I'm in the process of launching in India as a replacement for Western arithmetic. So if we consider going right back to the original Shunya, or the Big Bang, it's as if Shunya was decompressed, creating infinite magnitudes and multitudes from 0. So we've got the various theories, such as the zero-sum universe, conservation of matter and energy, Newton's third law: for every action there's an equal and opposite reaction. We have the mathematics of Aryabhata, Brahmagupta, Bhaskara, and blended in with the concept of symmetry, that all comes together as the form of mathematics called Podometic, which is symmetric zero-based mathematics. So let's consider that we've got a straight edge, not even necessarily a ruler like in this image. Imagine we've just got a straight edge and we've got a pencil. We mark a point, then we have a choice of which way we go. We can either go one way or we can go the other way. So whichever way we go first to draw that line, we can say that that might be a positive length or magnitude, and from that point, the opposite direction, we can say that's a negative magnitude or a negative line segment. And importantly, that means that from a single point, we have 2 lines emerging from it, one of them being positive, one of them being negative. And by allowing a point to take the form of a local 0, we can then update Euclidean geometry, which I've started to do, and incorporate the concepts of positives and negatives into ancient Greek geometry, which is pretty cool. So here in quite some detail is the original Sanskrit of Brahmagupta and his 18 sutras of symmetry for 0, positive, and negative, for the 4 main operations of addition, subtraction, multiplication, and division. So let's zoom in on addition sutra number 4. When positive and negative are equal, the sum is 0. And let's see how this works. So we've got 0, and let's assume that the black square represents 1 positive and the red square represents 1 negative. So together, the sum of those equal and opposite quantities constitute a 0. It's almost like you might say that the black represents a positron and maybe the red represents an electron. And when they come together, they annihilate each other. And mathematically, they won't release a photon, but they do cancel each other out and go to 0. So here's another form of 0, where we have 2 positives and 2 negatives. That again is a 0. So if we take away 2 positives from 0, you can see what remains are 2 negatives. So if I just replay that, that's 0. We'll take away the 2 black squares, take away the 2 black positives, and we see the 2 negatives remain. So 0 minus 2 positives gives you 2 negatives. Similarly, there's 0 again. Take away the 2 negatives, and we see what's left are the 2 positives. So we start to see the symmetric nature of subtraction on 0. And as an aside, subtraction actually commutes with regard to the numbers. It's just that if you subtract a larger from a smaller, the unit of the difference changes, which is one of Brahmagupta's laws. So what can we do? We can add integers to 0. And as you can see here above the line, I've added positives and negatives. And you can see they are of increasing quantity the greater the distance from the line. I've got it represented in 1 dimension and also in 2 dimensions with the squares. So as we can add integers to 0, we can also subtract integers from 0, as I just showed you a moment ago. So if we subtract those integers from 0, we get the opposite pattern appearing below the line. Now let's consider a physical interpretation of this. And let's say that above an x-axis, we are going to have a concept of positive work. And underneath the x-axis, we'd have negative work. And on the right-hand side of the y-axis, we'd have our positive quantities. On the left-hand side of our y-axis, we have negative quantities. So what we can also then do is we can then switch from the physical concept of work to the mathematical concept of the operations. And then we can start to say that instead of having positive work, which might be positive additions, we can just say, let's now map a positive multiplier above the x-axis and a negative multiplier below the x-axis. Now, before I mentioned we had a definition of multiplication, which is a into b is a added to itself b times, but then you've got 1 into 1 equals 1 added to itself 1 time, which equals 2. Now we know that 1 into 1 doesn't equal 2, it equals 1. So even though that definition has been around since 1570, it's been totally wrong since 1570 because it doesn't make any reference to India's 0. And that's what I noticed in 1968 when I was in class 2, and I argued with my teacher about how 0 was missing from the explanation of multiplication, and she was confused and she confused me, but that was the original spark of curiosity that I had when I was age 7. So the correct definition of integer multiplication is a into b, or a multiplied by b if you're in the West. A into b is either a added to 0 b times or a subtracted from 0 b times according to the sign of b. So let's have an instantiation of 0. And here we've got 0, we've got 6 negative squares, and we've got 6 positive squares. So now let's work through negative 3 into minus 2. Now you can see that the symbols represent different things. The superscript dash is negative, and the normal case dash is minus. Negative being an adjective, minus being a verb. So we've also got to, if mathematics is a language, we've also got to make sure that the mathematical expressions and equations also have the correct grammar, which very few people follow. So negative 3 subtracted twice from 0. Let's actually do it. We're going to negative 3 is subtracted from 0 2 times, so let's do it 1 time. We've taken away negative 3 from 0 1 time. Now we've taken away negative 3 has been subtracted 2 times from 0, and you can see what's remaining is positive 6. So negative 3 into minus 2 equals positive 6 from this very simple instantiation of 0. So let's go back to our Brahmaguptan plane, as I've called it, and let's have a look at positive 3 into plus 2. So that's positive 3 added twice to 0, and then we have that in the first quadrant. Now let's have a look at negative 3 into plus 2. Then we have negative 6, or negative 3 added twice to 0. What about negative 3 into minus 2? Well, that becomes negative 3 subtracted twice from 0, which, as we saw before, gives us positive 6 via the symmetric definition of 0. And in the fourth quadrant, we've got positive 3 into minus 2, which will give us negative 6. So if we go back to the first quadrant, we see positive 3 into plus 2 gives us plus 6. And now let's consider a symmetric rotation we're getting into group theory here. So let's do a rotation of our quantity in the axes, 180 degrees, and there we've gone from quadrant 1 to quadrant 3, and we can see that we've still got 6 positives after we've done that symmetric rotation, or that transformation in space, rotation in space. So from the physical foundations of Podometic and a symmetric rotation in space, we have shown why -3 into -2 equals +3 into +2. And you can see that they both give us the answer of +6. But now let's just have some concluding thoughts. So the power principles of Podometic, we've got in the first power principle is in class 1 or grade 1 at school. 5 or 6-year-olds can play with a bucket and spade to build bricks and holes, and using those pedagogies of bricks and holes with a bucket and spade, we suddenly make mathematics fun. And from ground level 0, children play with positive and negative quantities via bricks and holes. And it's very, very simple. If we've got a hole that's 7 deep, and if we've got a stack of bricks that are 4 high, well, the children can add those two quantities together. We've got -7 and we've got +4, and the children will drop the 4 bricks into the hole, and then they'll see that the answer is that they've still got a hole of 3, or the answer is -3 to the answer of -7 plus +4. And that's in class 1. We're introducing the concept of positive and negative quantities with total intuitive simplicity. So the second power principle of Podometic, or symmetric zero-based mathematics, is we have work on quantities is twofold, i.e. for every action there's an equal and opposite reaction. So given that our quantities are fixed and remain constant in our system, every addition in the system comes with a subtraction, and every multiplication comes with a division. So you can introduce the basic operations of what used to be called arithmetic 2 at a time. So the third power principle of Podometic is in Podometic Bhatia maths, all subjects are now empirical, intuitive, and fun. And the more children that we can get to enjoy mathematics at school, then we have more engineers, more scientists, more chemists, more biologists, more astronomers, and so on. So the principles of negatives and positives and exponent laws, negative fractions, and so on, some of the most complicated issues to understand and teach, are now all common sense for the very first time. Even ideas like, why is -3 by 5, or +5, why is -3 by +5 equal to +3 by -5? That's very complex for a teacher to explain, but children will know that intuitively and why it has to be the case. That's because we've rebuilt mathematics from physical foundations of physics that are consistent with the original laws of Brahmagupta and the definition of a symmetric zero. So if we look at, imagine that we've got a tunnel of light, and we've got all these barriers in the way, so we can shine a torch into one end of the tunnel, but we've got all these bad explanations of mathematics as the light that we have is perfect at the start of our education, but the negative numbers aren't explained correctly. It's all about rules, not reason. The integer ordering is wrong. The number words are confused. The laws of sign are all just about obey me and memorize them without the understanding. Same with index laws. And we learn simple things like multiplication makes more, but yes, sometimes it makes less. So the way that arithmetic affects the child's brain is, if you look at the brain at the end of this tunnel of light, you can see not very much of that child's brain has been illuminated with the correct mathematical foundations. And that's fundamentally why children around the world fear and fail mathematics and have a great phobia about it. You're very lucky, the people in this conference, that you're involved with technology. So you're one of the lucky people who enjoyed mathematics, perhaps, to get to where you are involved with science. Contrasted to Podometic now. So with arithmetic, we can see there's not much of the brain that's been eliminated. by the education in the first 8 years of school. With Podometic, we now have the correct ideas of mathematics in the first 8 years, and we can see that the child's brain is totally illuminated with the correct physical foundations of mathematics that describe how the universe actually works, and children find it fun and simple. So I've donated all my Podometic Bhartiya maths to the government of India, and this is a letter to the Education Minister, and I want to just thank you for your attention, and please send your comments or thoughts to feedback@podo.in, and that was why 0 is nothing without symmetry, and the era of arithmetic is over. Thank you very much.